Hello guys, today talking about the 1994 AIME Problem 9. A solitaire game is played as follows. 6 distinct pairs of matched tiles are placed in a bag. The player randomly draws tiles one at a time from the bag and retains them, except that matching tiles are put aside as soon as they appear in the player's hand. The game ends if the player ever holds 3 tiles, no 2 of which match, otherwise the drawing continues until the bag is empty. The probability that the bag will be emptied is P over Q, where P and Q are relatively prime and positive integers. Find P plus Q. So let's call our set A, B, C, D, E, F, A, B, C, D, E, F. And since it's asking for probability, we don't really need to care about which tile we need to choose first. So without loss of generality, let's choose A as our first tile. And we have 2 ways to go about this. We can go to AA, or we can go to A blank, where we choose a different letter that's not A. And so let's cross out A from the set. So clearly there's 11 letters left and 1 to choose from. And this is 10 over 11. Without loss of generality, make B the letter we choose. So now from here, we have to choose A or B as our third tile. Otherwise, we will lose because the game ends if player ever holds 3 tiles. So from here, we get 2 over 10. We need to choose A or B. So let's say we choose A. So AAB, AAB. So this cancels out to the remaining set if we choose this route is BCDEF. BCDEF. If the remaining route after we choose this is BCDEF, but it's missing a B. And these two are actually the exact same because at the start of each thing we have to choose one. At the start of each set, we have to choose one letter to start with. So these two are the exact same. And so what we can see is that A, B, C, D, E, F is equal to 1 over 11 plus 10 over 11 times 2 over 10, which is equal to 3 over 11 times B, C, D, E, F. And now we see where this is going. This looks like a recursive relation. So B, C, D, E, F. Taking a look at this, we get B can go to BB, or it can go to BC. And BC just means 1 over 9, 8 over 9. There's 9 numbers left because we have both A's canceled out and B canceled out. So that's 8 letters left. And so this gives us 2 over 8. And so BCDEF is just 3 over 9 times CDEF. We can continue this down. I won't show the work, but you get what I'm saying. Is equal to 3 over 7 times DEF. And DEF is equal to 3/5 EF. And now we don't need to keep on going because since we only have 2 tiles, it's impossible to lose. And the bag will always be emptied. And this is because the player can't ever hold 3 tiles. Because there's only 2 pairs, and if we hold 3 tiles, it'll automatically cancel out, and we will win. And so this is why the probability of EF is 1. So it means DEF, the probability of DEF is 3/5. The probability of CDEF is 9 over 35. The probability of BCDEF is equal to 3 over 35. And the probability of ABCDEF, which we wanted to find, is 9 over 385. Adding this up, our answer is 394. Nice problem. Thank you guys for watching. If you enjoyed the video, subscribe for more. Peace.